Now student, we are going to discuss question number 7.21, and in this question it is given to you, obtain the resonant frequency and Q factor of a series LCR circuit with L equal to 3 Henry and C equal to 27 microfarad and R is given to you 7.4 ohm. It is desired to improve the sharpness of the resonance of the circuit by reducing its full width at the half of the maximum. Find by a factor of 2. Suggest a suitable way. Now let us try to understand. In this question it is given, we have a series LCR circuit. We can say this is L, this is capacitor C, and we can say this is resistor. Clear? Value is also given to you. L value we have, this is 3 Henry. Clear? Value of capacitance, this is equal to 27 microfarad. Clear? And value of R, it is given to you 7.4 ohm. Clear? It is also given. So it is desired. So let's suppose it is connected with an AC source. Clear? Now our objective first in this question is to calculate value of Q factor. Clear? So for that one, actually we know this formula. This is given by omega R L by R. Clear? How can we calculate omega R? Omega R is a frequency at a resonant condition. So we can say omega R, this is given by 1 upon under root of LC. Clear? So if I write values of L and C, I can say value of L, this is equal to 3 Henry, and what about capacitance? Capacitance value is given by 27 into 10 to the power minus 6. Clear? So from here we can write like this. This should be equal to 10 to the power 3 divided by under root of 3 into 27. Clear? So from here you can write like this, omega R, this is given by 1000 divided by, now we can say, we can write this 27, 9 multiply 3, so this is equal to 3 multiply 3. So from here you can say we are getting this is 1000 divided by 9. Clear? And near about this value we are getting 111.11. So near about I am taking this is 111. Clear to you? So this is all about omega R. So if I put all this value of omega R, clear, because our objective is to find resonant frequency, we have calculated, and Q factor. So if I put this value 111 multiply, what about value of L? Value of L we have 3 Henry and divided by what is resistance R? Resistance R is given by 7.4. Clear? So from here we can write like this, this is equal to 333 divided by 7.4. Clear? So if you divide it, you can say near about, you can say 7 multiply 5 we have 35, 7 multiply 4 this is 28. So near about 28.5 you will get, yes or no? 74, just a minute, omega R L by A. Clear? Omega R L by R. Clear? Value of R is given 7.4. Clear? So this value you are getting, this is 7. So we can say 74. Yes, 74 we can say 28. So near about we are getting this value 45. Clear? So near about we are getting this value. Clear? So this is we can say all about omega R, that is resonant frequency, and we can say it is all about Q factor. Clear? Now we have one more question. It is desired to improve the sharpness of a resonance of the circuit by reducing its full width at half of the maximum. Okay, by a factor of 2. So let's suppose if we want to decrease the value of, if we want to increase, actually if we want to decrease value of width, actually you know this graph, actually if you draw this graph you will find this graph will be like this. Let's suppose we have these 2 points, and if we want to decrease this width by half, it means we have to increase sharpness by a factor 2. Clear? Now let's suppose if we are keeping this omega R constant, if I am keeping this omega R constant, for omega R constant L should be constant, the value of L should not vary. It means if we want to increase value of Q, I have to reduce value of resistance. Clear? So if I want to increase this Q factor by a multiple of 2, at that time we have to reduce value of resistance by a factor 2. Clear? So I can say, I am suggesting to you, if instead of 7.4 ohm, if you are utilizing 3.7 ohm resistor, at that time you can improve this Q factor of this circuit. Clear to you? So this is all about this question.